So hi everyone, I am Kayum, and in this video we will going to learn about the cyclic linked list. Okay. So in the previous video we have learned about the single linked list. So it is a quite similar concept from the single linked list that the single linked list can only goes in one direction. Okay. So you can attach a single linked list, right? And what about the cyclic linked list? Cyclic linked list is a kind of cyclic rotation. Okay, so you can go in the cyclic direction, right? So first let me show you that how it works. Cyclic linked list, right? So it will be in the both direction. Okay, and then it will come to the one, right? So this is in the cyclic manner, right? And we will see that how to represent it. Okay, so we will go with the similar initiation, right? We'll declare data argument, again data that will represent the data, next pointer that will represent the next pointer. Here this will be our cyclic linked list. Here only we will take the self, again self dot head is equal to none, then def. Okay, here we will check that if the class is empty or not. If the cyclic linked list is empty, then we will return self dot head is none, right? Now we will insert. So for inserting we will take value as an argument, and here we will say new node is equal to node and then say value. So it will create a new node for us. Now we will check if the self is empty or not. So if the self is empty, now what we will do, we will assign sub dot head is equal to new node, and then we will say new node next is equal to self dot head. This will connect the next node to the self dot head node, right? Here what we will do now, new node next is equal to self dot head. Here what we will do now, so else what will so self dot head, right? And we will loop this. Okay. So if the current dot next, if the current has next element and it is not equal to the self dot head, what we will do, we will say current is equal to current dot next. Okay, otherwise if this is not true, okay, then simply say current dot next is equal to new node, then new node next is equal to self dot head, and then self dot head is equal to new node. Okay, so this will tell the current pointer as current. This will tell the pointer current as current dot next is new node. Then what we will say, that new node next pointer will be the self dot head, and finally we will update the self dot head pointer to the new node. Okay, so this will swap the variables. Okay, so after doing this, now we will display. Okay, here we will print the current dot data. Hmm? Here we will say current is current next. After this, so after printing all the elements, it will print, it will goes to the new line. Okay, now what we will do, we will say for deleting the elements, what we will do, current then self dot head. Now simply current dot next not equal to self dot head. If current dot data is equal to value, then what we will do, current dot data is equal to none, current dot data is equal to current dot next data, then current dot next is equal to current dot next dot next. Okay, So this will simply change it. Okay, now we will say delete. Here we will say self.display. Okay, for I in range I display. Okay, so you can see this, right? This is a representation of cyclic linked list, right? Now if we delete, okay, so if we delete any element, for example we will delete 9. Okay, so it will simply tell us that this way this is deleted, and you can see 9 is no longer there, right? So if we goes for deletion of 2, okay, and okay, this is for end. Now you can see, hmm? You can see this has been deleted. Now what we will do, if we goes to 5, okay, we need to we want to delete 5, so it will delete the 5. So this is how we can create a cyclic linked list. Okay, so this is important. Okay, so the while loop will uh, check for this condition if current dot next element is not equal to self dot head, right? It will keep on checking this, and then what we said using the if statement, we say that if the current dot data is equal to the value we have provided, so we will say that make that value to none, then again make that none value to the next element. It means we are swapping the none element to the next element. Okay, and then we are saying that the next element should be the next element. So this way it will keep on eliminating it. It will keep on the none element to the end of the cycle, and then it will remove the none. So this is how cyclic linked list will work. Okay, if you want to have an idea about the size, we can do. Okay, while next not is equal to self dot head, then we will say then add 1. Here we will say size is size, right? And here simply say current is equal to current dot next. Okay, we can also check the size of the linked list. Okay, you can see size of the linked list is 5. Okay, so this is how it will work for the cyclic linked list. Okay, so if again we will see for the update. Okay, so if you want to update, okay, if you want to change the element, what we will do, while current dot next is not equal to self dot head. Okay, if current dot data is equal to value, then what we will say current dot data is equal to new value. Okay, and then say current is equal to current dot next. Okay, print value successfully updated. Okay, and then what we'll say self dot display. Okay, hmm. Now if you want to update, now if you want to update any element, for example we want to update 9. Okay, we want to update the 9 element, say mention the 9 with the what is the square root 81. Okay, so you can see value successfully updated, and you can see 81 is updated in the place of 9th. Okay, So this is how we can do. to Okay, you can see here, right? So this is how it can work. So this is how we can create a cyclic linked list. So we have seen how to create a node class, how to create a cyclic class, how to initialize the pointers, okay, head next data pointers, then check for the empty elements, empty node, then insertion, then displaying the cyclic linked list, then deletion, okay, inside a cyclic linked list. It is very simple as compared to other linked lists, okay. There is a one complicated linked list which is doubly linked list, okay. And this is size, and this is for the updatation, okay. So this is how we can create a cyclic linked list, guys. So guys, this will be helpful for you. Thank you for watching this video.